Well, good afternoon, everybody. I'm Joe Squire, your state construction materials engineer, and okay, good stretch over there, way to go. So you've all heard for the past 2 days, death by PowerPoint, how all these projects come together. Now we're going to build one finally, or we're going to talk about how we build them a little bit, but what the construction section does. That's not mine. There I am. So we're going to dim the lights just a little bit because I have a number of PowerPoint slides with pictures on them rather than words. Oh, by the way, the presentation you have in your books, we had a change order this morning, and so it's different. But the good news is that this is going to be online somewhere, and you'll be able to pick up on it. There's a couple of videos that we might try to add if I can go fast enough. And the other thing is with the lights dim, the folks in the back corner, if you snooze off, I'm calling you out, especially Mr. Oregon back here. All right, so what do? One of the first things we need to keep in mind is this right here. We're safe, okay? You heard Joe talk about it. You heard Susan Help talk about it. So I'm going to talk about safety first. At a night project, we pave 85% of our highways at night. And there's a couple reasons for that. There's less traffic, and so it's safer. There's less traffic, so big trucks can get in and out. If you have Wilsonville area freeway traffic and you're paving during the middle of the day, it is hard to get an asphalt truck or anybody else to that project site. But it comes at a cost. Here's the dump man who's telling the dump truck driver where to dump his load, and then we saw our inspector there, barely visible. Then you have this situation. The dump man's still in the picture. He happens to be right there. And so if you're an oncoming car and you see these bright lights, where's your eyeball go? It's just like the moth in the flame. You fly into the flame. Unfortunately, there's a person standing in front of you. As you're working projects, and I encourage you to get out into the field at night, in the day, whatever, visit your project site if you're engineering or environmental or whatever part of the role you play. Get out in the field. But understand there's consequences. In 2018, we had 4 people hit in the work zone. These are 3 of them, and then the 4th one escaped without being hit. I can tell you the one in the Monmouth area lost a leg. And what it was is a flagger. They got hit. We've also had employees get hit. A contractor's employee in the first one was hit. This was a drunk driver at mile point 207 over by Pendleton. The guy drove through the median and all spun circles, drunker than a skunk, found his way back to an employee that didn't realize this guy was doing donuts out in the cloverleaf, not the medium, and then finally hit him, flew up over the car, landed unconscious, which is fortunate from the point of view that he didn't die. And he came back to work, I think, about a month later. This is a police officer up in Portland, and for those of you in the Portland area, you knew about this. This happened just this year. This guy got hit by a 100-mile-an-hour vehicle. Both survived. The police officer escaped in a serious but stable condition with 2 broken hips. You can see in the corner here, this blue light is part of his Ford Explorer right here, and it's on. He had his flashing blues on. And I think, if but not for him, there was about 100 feet in front of him, 3 or 4 construction workers working on the bridge joint there. Very serious stuff, and as you're doing your designs or your layouts or what have you, whatever your role you play, bear this stuff in mind, because if you can make the work zone safer for everybody, we avoid this. She's dead. You know, and this is a person that was hit on Oregon 11. Oregon 11 is wheat country. We were paving at night, and I have to ask myself, why were we paving at night where the ADT is like 3 cars plus a cow? And we should challenge that. You know, we should be I'm not saying it would have been any different during the daytime, but I think her chances might have been better. This guy, 71-year-old drunk guy, hit her at 70 miles an hour. She flew 100 feet before she hit the ground, but she was probably dead on impact because there's a dent in his car that is 18 inches deep into the engine block. Okay. So, what does construction do? Let's get something a little more positive, but safety first. Construction section is not the construction folks out in the field. We help manage and monitor construction projects, but we're the administrative component largely, and we're the quality assurance. We're kind of the last stop before everything potentially goes sideways. We help solve problems, just like you all do. So within the grand structure of things, and I have a tie both to the chief engineer, that'd be Mr. Steve, and just like Joe said, be careful of who you work with because someday they may be your boss. Well, a year and a month ago, I was Steve's boss, and today he's my boss, and he thinks he is. So. But he is, and he's a great guy. But I also have David Kim, so I report to two people, one on the purely technical side with Steve, because Steve technically owns, through his delegated authorities and ORS, our specifications. David Kim owns the administrative component of it. But this is where the construction section fits in. We have 6 units there that we deal with, and I'm going to just kind of bounce through them one at a time here in a minute. But largely, here's what we do. We're first and foremost quality assurance at all levels, whether it's concrete, pavement, steel, process. How do we make a payment, and how do we make sure we justify it relative to the designs and the plans and the quantities that you guys all helped come up with. We looked at contractor relationships. Ever so important. It is a bad day for us as ODOT when a designer says in an email, and I've seen this a couple of times, don't worry about it here in the design, we can't get to it, we'll let construction take care of it. That is an automatic change order, and it's, if you've ever seen the thing, the yacht and the little dinghy behind, the yacht is the change order, okay? We also resolve disputes. We have some interesting disputes. Sometimes we have some comical disputes. Stuff that Steve has worked on in the recent past where overzealous inspection. Like, oh, thank God we had inspection. You know, it's those types of things. Or we have a current dispute in place or a claim for a $500,000 multi-use path, and we have a $5 million claim on it. We're not sure how the contractor figured that one out, but we will help solve that problem. So where we are and what we do. The construction section has staff spread out all over the state. So we're largely here in Salem, but we have staff in Ontario, LeGrand, Bend, Roseburg, White City. We have them in Salt Lake City and Spokane. Anybody know why we have anybody in Salt Lake City? Structures, exactly. We fabricate large steel bridge members over in Salt Lake quite a bit. Along here in Oregon, but every now and then there's a bid over in Salt Lake that's good. We have 2 people over there right now almost full-time and a couple of folks up in Spokane for similar reasons. And then of course we do a couple other things. We station crews with staff sometimes, like up in Barlow office in Portland area and whatnot. So the business services unit, quickly, they just keep the administrative wheels on the construction section. They help set up our annual AGC, ACEC meeting. If you went to that, they're responsible for that. They also help host a variety of construction meetings where we have them interaction with contractors routinely, which is hugely important for all of us. We actually hear about great design efforts that you do that worked really well, which means we also hear about the ones that didn't go so well and how do we correct that and get that feedback into you instead of just change order after change order. The contracting community is really important for us for 2 reasons. They are a true business partner in the fact that they provide constructive criticism rather than largely just throwing rocks our way. This unit that Steve used to manage was the contract admin unit, and probably within ODOT for most people, this is the most important unit outside of the chief engineer, I would say. And the reason is because this is where we pay our contractors out of. All the work that the construction crews do out in the field where they take measurement and payment off a survey and they equate a number of things and we document it, ultimately feeds up into contract payments. We do quality assurance check after quality assurance check, and I'll explain why shortly. And then we pay them, and we pay once a month right now. And on average, over the past several years, we pay out around $350 million to $400 million per year. The largest project that we've seen payouts on in a 1-month period on one project was $17.5 million in 1 month. If Rose quarter goes, we'll probably see payments in the order of $20 million per month. So that means you have to have your documentation in place, and we expect clean plans and specs too to help out that out. Within the quality assurance unit, that's out in the field. That's where we field test certain things, densities. We look at asphalt quantities or concrete or installation properly. We certify our technicians. We certify private sector technicians too. And if they run afoul of the standard specification, we pull their certification from them. Unfortunately for me, I'm the judge, jury, and executioner of that with evidence, and I've had to pull 2 certifications, none from within inside ODOT, but we will pull a certification from an ODOT. It is serious business if someone's cheating on test results. We don't want the concrete to measure at 2,000 PSI when you're expecting as a bridge engineer 4,000 or 4,500, because that bridge will break when we don't want it to. So within that, we sponsor trainings and certifications. We have inspectors and laboratories working on, for every inspector and construction lab working on a project. So in these photos here, everything from concrete to asphalt to embankments and a number of items like that that are measured in the field, we do quality assurance. The contractor is required to hire a qualified laboratory or materials testing firm. They provide, for example, on an embankment, 10 tests for every 1 test we have. We also have an independent assurance to double check to see are we accurate and they accurate at the same time, and then we marry them up statistically. If they're not, sometimes they get to pull it out and do it over again, whether it's concrete or asphalt or embankment. We want good, firm materials to build our roadways and bridges on. Within the training program, we do not online training, but we do in-person training both for technicians. So we partner with the Asphalt Producers Association, Asphalt Pavement Association of Oregon, APAO, and we'll send over to a live lab. The technician performs all the tests live. We're unique in that way. Other states don't do that. It's all book learned, and you get to take the test and off you go. Just like if you were in a class, in a physics class or something of that nature, and you have to learn about springs, you actually play with springs rather than theorize about them or what have you. Or you get to go out in the field if you're an environmental person and help catch fish or whatever, instead of dreaming about it. So we test them hands-on, and quite often they pass the written, but then they fail the practical. The same thing for inspectors, inspector certification. One of the things you'll see in a later slide is I would invite every one of you to take the general inspection class. I did a couple of years, actually several years ago now, and it is one of the best things for you to understand how our specifications, our plan sets, and whatnot tie together to ultimately generate a payment. So this fall, when you're sitting around kind of wondering, oh, what am I going to do next? Talk to your manager. It's a 1-week class. It's a relatively low cost, but you will be better for it. I guarantee it. You might, if you're a designer right now, you'll think, man, boy, did I really mess up on this one. I made it difficult for the contractor or our inspectors to understand. It'll help you out in that way. So central lab. The central lab is the pinnacle of what we do. We test a variety of materials all the way from plastic lumber is the most unique thing to a lot of carbon fiber lately that our bridge friends are having us test. And that's some interesting thing. We're trying to help develop new ASTM and AASHTO testing techniques, but to the more mundane things like concrete cylinders and asphalt pucks and whatnot. Our lab, I'm very proud of it. I would say it's unparalleled with a lot of labs on other DOTs. If there's a test to run, we can basically run it, and if we can't, we'll help you figure out who can, whether it's an academic person somewhere across the country or what have you. But largely in our lab, if you know what an 18-inch or number 18 rebar is, that's 2¼ inch diameter. If you've ever walked into the PDX airport, the strands that are holding down the walkway from the big temporary or short-term parking are number 18 rebars. It takes about 450,000 pounds to break one of those. We break them not routinely, but often enough where it shakes the whole building. 450,000 pounds of force released instantaneously. I'd make a $100 bet with anybody that wants to that you will jump. Even Matt Garrett. I think he even uttered a few cuss words. And the thing is we can tell you, hey, it's getting close, because you can see a meter where the stress strain is starting to get there, and when it pops, 450,000 pounds of force is released instantaneously. That machine can run up to, and it's this one right here, can rip something apart that's 600,000 pounds. That's the equivalent weight of an empty 747 with fuel. No fuel. That's a 747. So then the other thing, I mean, we do all kinds of lab stuff from geotechnical to soils to compressions to testing of any type. And so basically I say if you can break it, sort it, cool it, heat it, distill it, chemically analyze it, stretch it, weather it, compress it, tension it, and more, we do it with precision and accuracy, and you have to have both. So if you don't know what the difference is between precision and accuracy, there'll be a quiz next week, and I'll send out a note. Then we have structure services. So if you went to OSU, you probably remember a fellow named Keith Kaufman, and we had the big beam contest all the time. And Knife River is the kind of the pinnacle of big beams here in the state. And that's a large part of what we do. We test concrete, or beams or steel beams or whatnot at remote plants. And these guys get out and take a look at things. They're also responsible for looking at coatings on bridges, or even scour sometimes in bridge repairs at remote sites. Steve, I think you'll appreciate these. These are the beams from Pioneer Mountain. Who knows who at Pioneer Mountain Eddyville was? Isn't that cool? It's not the majority anymore. It was a big project. It was going kind of okay, then it went not kind of okay, then it went really well. But we were going to have bridges. We didn't have bridges, but now those bridge beams are sitting up at Newburgh Dundee. They were repurposed. This bridge beam right here is the largest one that Knife River now produces. It's called a BT90, bulb T. It's 90 inches deep. It's 185 feet long. It's a really cool thing around fish streams because I can avoid midstream bends. So if you can get the elevations that you need. We do a lot of things from structural steel to there's one of those beams going in. And then we help with the bridge group, take a look at why do we have failures? And we go and collect samples and analyze those materials. Pavements. I'm not going to talk a lot about pavements because Karen Strauss is right after me. She's our pavements design engineer and she'll be rolling in here. Other than to say our pavements unit is one of the more unique units in the state. It was extremely well run by a young lady named Lucy Moore, who will be coming up here shortly after. And if you haven't met Lucy, she's a dynamic person. But she ran pavements for a long time and helped set the course. And where pavements is, we're involved in planning, design, construction, and maintenance. And so we see that full gamut of that circle right there. Now we're involved in more or lesser degrees, but if you ever take a look at the pavements report, that's produced by our section onto how good or fair we are. And the great thing about Oregon, we're running about 85–90% fair or better, which is like tops in the nation. So again, and we do both concrete and asphaltic pavements, or PCC, Portland Cement and Concrete. So our tools. First one you should use is your brain. Okay, this is not in your book, but if you don't engage your brain, then you probably don't belong here. But because you've engaged your brain, you are here, so that's a good thing. Then we talk about the teamwork, and that's the thing is that you're a bigger part of a team. It's not just Joe by himself. And then precedents. We talk a lot about precedents because if it worked in the past and the conditions haven't changed, that's a good thing. But if it didn't work, we avoid that so we don't set precedent and one-offs. Just like everybody, we have tons of manuals. I'm not going to go into manuals. So I was asked to talk about deviations. The primary deviation we have is no one in construction expects any plan set or specification to be perfect. And the thing is we do have a tool, and it's change orders or extra work for things that are missed. What we don't like to see is a repeat or things that it's like, I just couldn't get to it, so let's just let construction deal with it. We don't want to see that either. So, but we do have a change order process. It's rigorous. The professional of record, whether it's the environmental person, the design engineer, the bridge engineer, the roadway engineer, whoever, is generally involved in that change order process, as well as the contract admin engineer and the local construction crew primarily and first and foremost. How are we QC'd? We're an interesting group, I think, from the perspective of we have quality control from forces we don't see coming in sometimes. And again, this is different than your books, and you'll get this outline, but Oregon Department of Justice looks at us a lot based just on our specifications, how good are our specifications, both special provisions and otherwise, to say this is going to be contractually enforceable or not. It's a QA function, or QC. We do lots of federal audits, which we have survived, I'd say every one of them. Sometimes they take longer to get through than others. But this is the type of stuff we go through on a routine basis. AASHTO is the American Association of State Highway Transportation Officials, if you don't know that. And AMRL is the AASHTO Materials Reference Laboratory. So we get random samples from AASHTO. It might be red Georgia clay. We have to run the gradations and sieve analysis and a number of plasticity tests and whatnot. And it's kind of like that blind sample. We send back our results, and then AASHTO says, yep, Oregon, you passed, or hey, you're a little bit deficient here. So it's a very independent check. The CCRL is for the concrete side of the world. So milestones and deliverables. You heard about first note. That means first notification, by the way. That's when we first tell the contractor you're good to go to work. Second notification is all bid items are complete. And then third notification is project's done. So all bid items complete has to be by the project completion date. Otherwise, liquidated damages are imparted to the contractor. That's a longer story. But we also take a look at quarterly. The contract admin unit has what's called a region assurance specialist. It goes out to every project management construction crew and quarterly walks through their documentation. The importance of that is if we start to accept materials that are substandard or not qualified, for example, if we had a bunch of steel show up in a bridge that came from China, and let's say it's all the rivets. Real case in Oklahoma, they had $10,000 worth of Chinese rivets show up in a $700,000 bridge. That bridge became what's called non-participating in the Federal Highway Administration world. And so Oklahoma had the choice, tear down the bridge, try again, or suck it up, and they paid the feds back their balance of the federal participation, which was on the order of $650,000. So we take a look at a lot of things like that with RAS-type reports. So do we have our Buy Americas? Do we pay the contractor properly? Can we release retainage as a matter of routine rather than the very end of the job? We also do, finally, at the bottom, of a lot of statewide reporting. You're going to see online right now on time and on budget delivery, and that's from the construction side. If the design side does a very good job, or I just say a good job, we're probably going to be okay on that side. If we have lots of, hey, let's let construction handle it, it gets a little more difficult that way. Our interdisciplinary coordination, we coordinate with everybody. And the most importantly, though, is the construction crews and the project delivery. But another piece, and I often ask this when I see some variable coming along, did you ask maintenance? By the way, if you've never worked on a maintenance crew, you should go to work on a maintenance crew. It's really good. You'll see a roadway, you'll think, man, those stripes are either good or bad. Or you'll think, oh, that shoulder's a great shoulder, way to go. You won't look at pavement the same way. Oops. Practitioner's minute, that's me. I always think safety. If it can happen, it might happen. And so don't be complacent. You know, complacency kills. It's always the right time to do the right thing. Yesterday I heard, and it's not a criticism of Carol Cartwright, she mentioned something comes in late to the project at advanced plans. You know what? It's better to fix it in the planning stage instead of shipping it to construction, because if it gets shipped over to construction to fix, oftentimes it can land in maintenance, and that is just like a bad, bad deal all the way around. So fix it at the earliest point possible. It's always the right time. Integrity is key. I've helped defend engineers, and Steve has too, that says, I can't stamp this because of X, Y, or Z, and someone's applying political pressure. Maintain the canons of your profession. The big one that I always get to, and again, since these aren't in your book, this was a change order that go away. That's for Leslie. I stole her card, so she can't give this to me. And I'm running 20 minutes ahead of time right now, so that's cool. Avoid the Google flyby. If you haven't gone out in the field and looked at your project, you're not an engineer or a scientist or a technician. you have to go look at it at least once. Even if it's at 55 miles an hour, it's better than the Google flyby. Avoid that. Ground truth that. Talk to the construction crew that's building the project. How's it going? Did I get my environmental clearances proper for you? Did I get the right-of-way lined up? Did I get the survey? Did you have to redo the survey? It's things like that that'll help you become a better professional. Key context, no big deal. So, hey, we're all in the phone book. So I think I'm going to get this right. So this is a project Joe Thomas was the construction project manager on. This is the before. I was a tech center manager at the time, and this was my first big one out of the chutes, and I won the bet on what the bid would be. It'd be within $500,000, and I said $660 million. It was 59.7, and so I win. Wildish Construction did this. Region 3 designed it with the exception of the bridge, and that was Lochner at the time. And Knife River provided a lot of the bridge beams, and I think this will get this right. Yeah, there we go. So that's the new interchange, and that was a really cool project. This was down in Medford area about 12 years ago now, but this is the type of thing that if everybody gets their team and their act together, we can do really cool things for community. What's interesting to me is prior to this interchange here, there was no development right here at all. This probably sprang forward, I'm guessing, probably $20, $30 million in new development, new jobs, new everything for the community down there. Was long suffering around that. And that's what that structure looks like today. And if you'd ever been down the Medford area prior to this project, you knew that Barnett Road was just a pure bottleneck to get from one side of the freeway to the other. Interesting story, things you run into. So Jim Collins was talking about the Migratory Treaty Bird Act. That happened on this project, and a fellow named Doug Tyndall, who was our deputy at the time, said, hey, got to comply. So we did. We had to go cut down all the trees before March 15th, which we did. Well, our maintenance crews are out there mowing down the blackberry because it's 10 feet tall. And before we do that, there's homeless camps. And we call out, and if you haven't experienced a homeless camp, they will tunnel very carefully by clipping the blackberry into the blackberry, and it becomes their little home. So we make it very purposeful, and I see Lucy nodding her head, and I expect her to jump up and say, no, you're wrong if I'm wrong. They call out, they pitch rocks in, they pitch sticks in. Hey, is anybody there? No one's there. We go in there, and we're weed whacking with one of these big flail mowers. All of a sudden, a sleeping bag goes flying, and here comes an arm, and the whole works. Someone had a blow-up doll in a sleeping bag. But it scared the crud out of a certain maintenance person. Just saying, life happens. But okay, all right. Hey, Lucy, it was a real moment. Got to keep it real. So talking about real moments, and hopefully I get this right. Let's see, it's not a touch screen. This is a video, and I think we might have sound with this. There we go. I want you to watch proximity to traffic. Maybe kill the light all the way if we can. This is US 30 up by Linton, west of Portland. 45 mile an hour. This fellow here has CB headphones on so he can talk to the truck driver, but what really bugs me is watch how he pays attention or not to the traffic. Now he's going to walk between them, and here's what really bothered me. Our cameraman followed him. So that noise you're hearing, the machine in the front, is actually picking up the asphalt that's been laid and placing it back into the hopper. The asphalt, remember, is running around 280 degrees Fahrenheit. So our cameraman's standing between that roller and the rail. Where's his escape route? About done here. And you can see that is not effective. In some cases, and very intentionally, we've had flaggers, and I appreciate that they've done this, although I probably shouldn't say that out loud. They've reached out and hit a speeding driver that was coming in the work zone with their paddle to just grab their attention. We'll move on to the next one here. This is basically, so this was in reverse order. We were paving and then all of a sudden we're putting down the tack and then we're grinding. So that's in reverse order. I couldn't quite convince our video guys a couple of years ago to reorder this thing. But you get the point. Now, that's how we typically do it at night. So imagine that fellow walking between the two trucks there at night. And you know, his reflective vests will work to a point, but if you've ever been around an asphalt crew, their reflective vests get pretty damn dirty pretty darn quick. Let's see. This is how we'd like to do it. This has no sound. Joe Thomas's group flew this for us. They are not over traffic. They're over the edge of the right-of-way. You're not allowed to be over traffic. But an interesting thing here is as the video reverses and you're looking towards the direction of traffic, you'll see that cars actually move over to the fog line. This is Oregon 569 down the Eugene area. This was done just last summer. This is a pilot project that Steve and I would say Director Garrett helped push through. Oh, it was Brett and company. These guys over here flew this thing. It's a great piece of video. I love this backhoe. If you look over on the far screen that I'm pointing at, he's coming right here. Watch him bounce. He moves that pickup truck over. He bounces right there really well. But you can see, most importantly, see how the vehicles are moved over and away from the center line, which is a good thing. And that's what we'd like to see, is a good hard barrier between us and the construction zone. We actually believe the quality of the work goes up because while folks still need to look over their shoulder and look out for each other, now they're not looking for that 70-mile-an-hour vehicle coming at them or worse. So that's really the end, so I can go away. I'm done. Thank you. All right.